Alright guys, today I'm going to do a quick lesson on waves. You guys should have done something with waves in physical science, but actually, those are like sound waves and different things like that, but the parts of the wave are the same. So we'll talk about that and then different weather phenomena that happen with waves, okay? So a wave is the up and down motion of the ocean surface. As the wind blows, it pushes the ocean surface, causing the water to lift. So the harder the wind, the bigger the wave, the gentler the wind, the smaller the wave. I'm sure you guys have been over the Neuse River Bridge before and the water looked almost perfectly calm, and then you can go over it another time and you can see whitecaps, small whitecaps, but you can see whitecaps, and that's all because of the wind speed, the amount of time the wind blows over the water, and the distance the wind blows over the water. But the bottom line is waves are caused by the wind, and then also the depth of the water. Okay, so the wave height is as tall as the wave is. Okay, so that's measured from the crest to the trough, and we'll talk about that in a minute. And it can only be measured when a wave is parallel or perpendicular to the ship. So how they previously would do that is the captain of the ship would actually know how tall the tallest part of his boat was. It usually was a mast or where the radio antenna was or something like that. And he knows that's a right angle to his ship. So if he could figure out the height of the wave because he would know this distance on his boat and he would know this distance on his boat. So he could use the Pythagorean theorem to figure out how tall the wave is. So who said you wouldn't use math when you're older? But of course, nowadays, modern times, we have actually, buoys and different things that measure wave height, so we wouldn't have to use the Pythagorean theorem to do that. Okay, so a wave train is like a series of waves that come one after another, moving in the same direction. So if you have a wind that is blowing steadily, you would get a wave train. Okay, one right after the other, right after the other. And it's pretty synchronous, like you can kind of time it and predict it. Okay, so you can determine the speed or velocity of a wave if you know the wavelength and the period. So the wavelength is characterized by this symbol here. I think it's called lambda. And then, of course, t is time. Okay, so the wavelength is the distance between two crests or troughs. So if you knew this distance from crest to crest or trough to trough, you would just have to divide that by the amount of time it takes one wave to pass a specific point. That's what a period is. So it might be 2 seconds, 5 seconds, whatever, and then you can figure out the speed of the waves. Nowadays, we actually have like little buoys in the water, and they can measure that as they go up and down with the wavelength. They know the time, and it can figure out the speed for you. Okay? So let's label this so you're aware of that. This is what I was saying that you learned in physical science. The crest is the highest point, okay? The trough is the lowest point, so that would be down here, all right? Then the wavelength is the distance between the two, so that could actually go here, or, of course, it could go here, all right? Either way, it doesn't matter. And then this over here would be the height or the amplitude. So that's a fancy word for the height. That goes right here. Okay? And remember, it's measured from the midline up. It's not measured from the crest down to the trough. That would be twice the height. You need to measure it from the midline. Okay? So like as an example, when a surfer's out there and he's like, oh, those are 10-foot waves, he's not measuring it from the lowest point to the highest point. He's measuring it from the surface of the ocean to the highest point. Okay? All right, so circular orbital motion, this is what waves do. This is one reason that people feel so tired after they've been in the ocean. And my little link here isn't working, so I can show you. I'll try and find it and post it. But if you watch this video, because waves move in this particular motion, it looks like that seagull is moving forward, but actually he's only moving in a circle. Okay, because the individual water particles do that, and this picture is also showing that as well. Okay, so like I said, that's one of the reasons that people are so tired or have to have so much stamina if they're surfers, because they're constantly moving in a circle, And then if they want to go towards the beach or further out to the water, you have to swim and fight this circular motion. Okay? All right, so let's talk about when waves break. There is actually a formula for that. Okay? When the water depth is about half the wavelength is when the water will tip over the top, it pitches forward, and it'll break. Okay, so obviously that's what surfers are looking for, right? They want to be on the wave as it breaks. So you can kind of predict that, okay? If the water is about 10 feet deep, then you want something that's about a wavelength about 20 feet. So you would want 20 feet between the two crests or troughs. And, you know, they can visually figure that out if they've surfed for a really long time, okay? So this is how it works. Notice the depth of the water is getting shallower and shallower as you go towards the shore. That makes sense, okay? So the waves start to crowd here. They get taller and taller here because the energy is pushing them forward, all right? And this is what we call the surf zone, right? The back of the wave is moving faster than the front of the wave, and it becomes too heavy, and it falls over. So remember, this distance, okay, when it's about half of the wavelength is when that's going to happen. So if you have waves that are really close together, it'll happen further offshore. If you have waves that are further apart, it'll happen closer to the shore. Okay, so the calculation is the wavelength divided by the period for the speed. We've done that one. Okay, and then you can also do half the wavelength or 1.3 times the height. So if a wave is 15 feet tall, then it'll probably break at about 18 feet out. Okay, that's the way you can do that. All right, so let's talk about white capping, which I mentioned a minute ago. Like you can even see it on the Neuse River. So strong winds produce really steep waves that are narrow, like these. So you can see pictures of white capping out here. A lot of sailors or people who are on ships and fishermen and stuff don't like white capping because it's constant motion on the boat, and if you're seasick, that's a bad thing for you. Rogue waves are just when there's a lone wave that's really high, and it could be two that have combined, and these are dangerous. These are the kind of waves that can turn over smaller ships. Okay, and this is a tidal bore. Y'all, this doesn't happen in North Carolina, and I'm pretty sure that this picture is photoshopped. But it makes me laugh because these people here are just sitting here when this huge tidal bore is happening behind them. So anyway, it's when the seafloor at the mouth of a river slopes gently and the range is bigger than 5 meters, which of course is 15 feet. It rapidly advances up the river, and of course it can cause flooding and death and destruction. So just say these people are 5 feet, just to do some easy math. You can definitely tell that that's at least 15 feet of a tidal bore. Okay, and the last one that I wanted to work on with you is a tsunami. Okay, this literally translates to harbor wave, and we incorrectly call it a tidal wave because it has nothing to do with the tides. All tsunamis are created by a disturbance in the Earth's crust. So it could be an earthquake, a landslide, a volcanic eruption, whatever. And as you know, when those things happen, a great amount of energy is released. Okay, so the waves are fast and they have really long wavelengths and periods. So you might have 5 minutes between tsunami waves. Okay, but as they slow down, the forward motion is converted into a lifting force, which is a giant wave. All right, so they do have tsunami warning systems, like in Japan and other places like that, because obviously an earthquake can be detected. So the further offshore it is, the more warning you can give the people on land. And there are actually sirens and stuff that go off, similar to what we do with tornadoes and things. Okay, and the good thing about a tsunami is there is a little bit of a warning. Okay, y'all, it may not be more than 15 or 20 minutes, but it is a warning. So you can get people out of hotels or off the coast if they're on a beach or something like that. And these are very common in Asia. And there has even been a tsunami warning in Hawaii and on the west coast. Okay, so the good news is they have good earthquake detection systems, and then they can kind of warn people about a tsunami. All right, so guys, that's our short lesson on waves today. So if you could complete the assignment for me and email me if you have any questions or concerns, and have a great day.